Today we are going to discuss about packing of spheres in solids. We all know that solids are rigid, they have definite shape, incompressible and have orderly arrangement. Two types of solids are crystalline solids and amorphous solids. Crystalline solids have long range order and they are anisotropic in nature. Amorphous solids have short range order and they are isotropic. Here we are going to discuss packing of spheres in crystalline solids. Let us know what is meant by packing in solids. The packing of atoms, ions or molecules in a crystalline solid can be arranged in a number of ways. The arrangement in which the maximum available space is occupied is known as close packing. The closer the packing, the greater will be the stability of the close packed structure. In a crystal, the particles occupy the lattice point in the crystal lattice. Here, we can see that in a crystal, the particles occupy the lattice points and the particles may be of different shapes and the mode of packing depends upon the shape of these atoms. And also, the atom should be rigid, incompressible and of equal size. Now, let us discuss different modes of packing in close packed structure. The first one is close packing in one dimension. In one dimension, there is only one way of packing the crystal lattice, and here all the atoms are arranged in a row and each sphere is in touch with two of its nearest neighbors, and the coordination number in close packing in one dimension is 2. Now let us go to close packing in two dimension. Close packing in two dimension can be generated by placing the close packing of spheres in row and it is placed horizontally. Here we can arrange two different ways for the close packing in two dimensions. The first one is square close packing and the second one is hexagonal close packing. Now let us see what is square close packing. Here we can see the first layer, that is A, that is same as square close packing in one dimension. Now we are putting the second layer just exactly above the first layer and the third layer is just exactly above the second layer. Here the first layer is marked as A and the second layer is also marked as A because it touches with each other and all these rows are aligned horizontally as well as vertically. So this type of arrangement is known as AA type arrangement. Here we see that each sphere is in touch with 4 of its nearest neighbors and the coordination number in square close packing is 4. If we draw a line by connecting the centers of each spheres, it will form a square. That is why this packing is known as square close packing. And the packing density is very less. Second one is hexagonal close packing. In hexagonal close packing, the second layer is placed above the first layer and the spheres fit in the depression of the first layer. So the second layer is not exactly the same as the first layer and it is represented as B. Now, if we put the third layer above the depression of the second layer, it will be exactly similar to the first layer. So it is again noted as A. So this type of arrangement is known as ABA type arrangement. Here we can see each sphere is in contact with 6 of its nearest neighbors. So the coordination number is 6. And if we draw line connecting the centers of each spheres of its nearest neighbors, it will look like a hexagon. That is why this structure is known as hexagonal close packing and the coordination number is 6. Here we can see a triangular site voids. Here two types of voids are there. These all are triangle in shape. In the first row, we can see that the apex of the triangle is pointing downward and in the second row, we can see the apex of the triangle is pointing upwards. Now let us see close packing in 3 dimension. In close packing in 3 dimension, it is generated by placing the layers of close packing in 2 dimension one above the other. This one is a close packing in 2 dimension. As I told you earlier, here we can see 2 types of voids. One is the hollow marked with dot and the other one is the hollow marked with cross. The second layer can be placed either above the hollow marked with dot or above the hollow marked with cross. But it is not possible to put the second layer simultaneously on the hollows marked with dot and cross at the same time. Now let us see what will happen if you are putting the second layer above the hollow marked with dot. This one, let's see that this red one is the first layer and this dot, and we are keeping the second layer in the hollow marked with dot. That will look like this. The green color layer is the B layer, and here we place the second layer above the hollow marked with dot. Here we can see there are again different types of voids are there. The first void is the hollow marked with cross, that is still unoccupied layer of the first layer, and the hollows formed from the second layer. So when you are putting the third layer either above this cross or above the hollow formed from the second layer, we will be getting different types of packing. That packings are known as hexagonal close packing and cubic close packing. Before that, let us discuss what are the names of these voids or hollows. This is a schematic representation of this one. Here two hollows are marked with two colors. One is with blue color and the other one is with red color. These two are known as hollows or vacant sites or voids. And what is a void? It's an empty space between each spheres even in a closed packed structure is known as voids. So here see, this is arrangement of spheres in a triangular fashion. So here I have arranged the atoms in a like a triangle, and the empty space between this triangle is known as a triangular void or triangular site. Now I am going to put the fourth sphere above this triangular site. It will look like a tetrahedron. So what is a tetrahedral void? It is a void formed by connecting four spheres in a crystal. And the other one is octahedral void. Octahedral void is the empty space formed by connecting six spheres. Here the arrangements are like that. Here we have arranged three atoms like a triangle, another three atoms like another triangle, and they are connecting with apices connecting in opposite direction. The empty space between these six spheres is known as octahedral voids. So here we can see two types of voids in this A and B layer. The first one is the blue color is a tetrahedral void and the red color is the octahedral voids. Why we are calling this as the tetrahedral voids? Let's see here. This blue hole is connected with 1, 2 and 3 spheres of one layer and this sphere of the second layer. That means this blue color or the void is connected with 4 spheres. That is why it is known as tetrahedral voids. And see here this red hole. This red hole is connected with 3 spheres from first row and another 3 spheres from the second row. So that means that red hollow is connected with 6 spheres. That is known as octahedral voids. Now we are going to place the third sphere or third layer above either tetrahedral voids or octahedral voids. We cannot put the third layer simultaneously in both hollows at the same time. Now let us see what will happen if you cover the tetrahedral voids. This again I am repeating the same picture. This blue color is a tetrahedral voids and this one A layer, B layer, and I am going to put the third layer above this blue, that means the tetrahedral void. Let's see what will happen. Here this is the blue color. If I am putting the third layer above this circle, see here this will be same like A layer. So that means here the red one is A, the green one is B and the blue one is again it is same A. So that means this has a AB arrangement. Another name for this one is hexagonal close packing. In hexagonal close packing, the coordination number is 6. We already know that hexagonal close packing structure, each sphere is in contact with 6 spheres from the A layer. Then this sphere is connected with 3 spheres from the B layer. Again down also we have another layer, so that sphere will be connected with 3 other spheres in the bottom layer. So, the total coordination number for hexagonal close packing is 12. Now, this is the three-dimensional close packing structure of HCP. Here it is clear that this sphere is connected with 3 spheres from the first layer, 6 spheres from the first layer, 3 spheres from the second layer, and again third layer also same like this, it will be repeating. So, total the coordination number is 12. Now, let us see what will happen if you are covering the octahedral voids. As I told you earlier, octahedral void is the void formed between 6 spheres. So, this is the octahedral void. Now, see, if I am putting the another layer above this octahedral void, this will be a new layer. So, that is represented with this blue color circle, that is known as the C layer. So, A is different, B is different and C is different. If I am putting the fourth layer above the C layer, it will be same A layer. So, this type of arrangement is known as ABC type arrangement. Another name for this arrangement is cubic close packing. Now, we can see the three-dimensional cubic close packing structure. Here, it is also known as face-centered cubic structure. Here also the coordination number is 12. Now, let us conclude. Here, let me revise what we have studied today. Today we have studied about packing in solids and what is meant by close packing. What is a close packing? It is the arrangement of atoms in maximum available space is known as close packing. And we have learned different modes of packing like 1 dimension, 2 dimension and 3 dimension. We all know that as the packing density is more, the stability of the crystal lattice will be more. And we learned also hexagonal close packing and cubic close packing in 3 dimension, and we also studied about interstitial sites or voids in the crystal lattice. Thank you.